Good afternoon. Hope you had a great day today so far with the keynotes and a lot of information, a lot of good participants, and a lot of good audience. So thank you for making a time for attending this session. As you see, today's session would be based on instantaneous replication of build artifacts using NetApp. How many in the room actually know who NetApp is? Great, quite a few hands. Fantastic, thank you. So we are basically a data management organization. We manage data. So what you see, the rest of the presentation today, what we have done with JFrog, because JFrog is a tool which is a universal binary artifact manager. How does that actually have relevance to what NetApp is doing and how we are doing it? So we're going to talk about that. Primarily think about this as a distributed sharing that you're doing, the file sharing across different locations. Maybe just a bit of introduction about myself. My name is Bikash Choudhury. I'm a principal architect from NetApp. I've been in this industry for a long time, and very recently I've been focusing, I wouldn't say recently, it's been more than a couple of years now, focusing on DevOps and solutions around DevOps for my data management capability and the partner ecosystem that we are trying to engage and integrate and validate a lot of our solutions to address very specific business problems and challenges.
All right, thank you, Bikash. So, hello everyone. My name is Edmilson Peixoto. I'm a solution development director at JFrog. So I'm responsible for the partnerships and customer integrations. Before JFrog, I worked at Ericsson for 16 years, always as a software engineer and also as a head of continuous integration delivery organization. So we supported 4,000 developers with 6 products in the IP and cloud organization. And we had several challenges. And I just want to start asking you guys, how many of you use Artifactory here? Oh, yeah, of course. The best tool in your universe. And how many of you use replication in a multi-site organization? All right. So what I want to talk is a little bit about distributed development very quickly before we go to our main topic of today's presentation. So distributed software development has become common, especially in large organizations like Ericsson, the company I was at, that we have several sites in separate locations. So this presents a lot of challenges to ensure that development teams, they work in a consistent and also synchronized code base. And to ensure that the proper development is done, we need at least to guarantee some points here. For example, ensure all developers are using the same versions. I would say even not the same, the right versions, right? And when I say the right versions, could be snapshots, could be latest, or could be the blessed versions. You don't want the situation that the developer really doesn't know which one it is. So we can choose between the beer or really a golden artifact, right? This can happen. We want your teams to be consistent and also synchronized. Reduce the risk of network latency and instability. Now we know there are laws of physics, they govern the propagation delays. However, if you put like a right design, optimization, and the right technology, you can minimize those delays and also minimize the issues with stability. So ensure all your artifacts are shared efficiently with global teams. Okay, via topology, right topology network, Artifactory advanced features like remote replication, virtual replication, push, multi-push, and also pull replications as an example. And also be sure that you can access specific versions of remote artifacts. This is also important in many cases. Okay, those are some examples. And to overcome that, Artifactory has a lot of features in terms of replications and also topologies that can help your business needs. But today, I want to talk about a very interesting use case. So we had a customer, it's a global automotive company that had a use case and it's a common customer for NetApp and JFrog. So their use case, they need very fast propagation of data around the globe in 4 different geolocations separated, right? So the data is pretty much the common denominator between JFrog and NetApp. And fast propagation is what we want to deliver in this use case. So Bikash, how NetApp can help us with this solution?
Great, thank you, Ed. And just to see what data does and the volume of data, and data has gravity. You just can't just get your data moving around as you wish. If it's a small data set, then yes, probably. But again, if you're doing cross-site replication of your data, mobility is restricted with your WAN latency, which is still there in this integration too. We're not getting away with that. But we do things a little more smartly. And the reason why, because I would like to ground this situation or the challenge that we're trying to drive here with 2 different things. Customer says, oh, I actually have a caching ability, which I can cache into my local sites on demand, and then I can leverage that caching ability of the data function, do my job, and then put the data back into the central repository. Great, that is one of the use cases. Second option would be to replicate data. When you replicate data, what happens is your destination has a read-only copy. You don't have ability to write to it unless you break the replication and make it a read-write, and then you resync back so that your data is synced back to the destination again. So there is an overhead and challenge of how you do that. I wouldn't say more of a challenge is actually a specific use case that it drives. But when you're doing or working in a distributed environment, when you have got skill sets that are spread out in different locations, supposing somebody is building something, developing code, and your QA team is sitting somewhere else, how do I actually enable them in their time zone, have the data available locally, instead of prefetching the data? There is no mechanism of prefetching data in your caching mechanism. It has to be on demand. Your cache is not warmed. It is cold cache. You're going to first warm up your cache before you start working on it. So when you have a scenario like that, then obviously you need to wait for the entire cache to be warmed up before you can start doing it. What if you do not have a specific block in that cache? You need to go back to the origin again. So a lot of these challenges are mitigated by a distributed form of file sharing, where JFrog and NetApp together can actually make sure that this integration would actually work. So let's see some of the work that we have done. Let's get off to start where we talk about what was the advantage. What is the advantage? We did test with a very popular hyperscaler like AWS, cross-region replication, which a lot of our customers are doing. And we did a similar test with JFrog on NetApp technology to compare where the baseline is and what's the difference in the performance. And we found out with 170 millisecond latency, we were able to achieve 6x performance improvement. That is a significant improvement, not just the performance, but the cost of having the replication and the storage to support the data. Because when you go into a hyperscaler, your entry point is always free. But as you keep on growing, you occupy more space, you take up more space, that is chargeable. And then you have to replicate it to a different site in a multi-zone environment, if you have got different availability zones, or for the matter, want to move it over to a different cloud. Because as an user, you do not want to be dictated by some specific vendor and have a vendor lock-in of the data. And that's what NetApp provides, that you don't lock in your data anywhere. If you get a better price in Azure or some other hyperscaler, you're absolutely free to move around. And that's the flexibility NetApp provides with the data mobility, as well as the performance and the overall cost and the experience of using and having the data available at any given point of time for your application. So the challenges that we were actually dealing with most of the time is how do I sync my different sites instantaneously for developers to not wait for it, because at the end of the day, if you remember today the keynotes when Melody was presenting, it's all about developer productivity, faster time to market. How do I actually take my local teams doing here in California and spread it across my global geos and make it more productive and improve my time to market. That's what the end goal is. So that means I'm going to look into more of a distributed setup where I'm sharing files. And the other key thing is, as you move from files to object, from object to files, as a developer, you don't have to really care about the data continuity. You don't know where the file is, where the object is, in what format. You don't care. So who takes care of it under the covers is this integration that we have done with JFrog is completely transparent to the developers. They don't care about all of that stuff. And then finally, protecting. If you lose a file in one side, somebody accidentally deletes a file, you have got tons and tons of versions of builds that are coming out in a single day or in a week or a month. That adds cost to your storage. But how do I can have a better, cheaper, and faster storage, which can actually have all of cheap and deep storage for all my build repositories, and which has been managed by Artifactory. So if I layered this up, obviously in the CI/CD workflow, you have got JFrog sitting right there, the Artifactory. And then you have got the access layer, which is the protocols that you would be using, either files, which is NFS or shared file system, or an S3. And then the endpoints that you have at the bottom, where your data manageability is happening. Where do you manage your data? Is it sitting on a fast-performing storage, which is actually managing your data and providing you the high availability and the performance that you're looking for your builds, parallel builds that are happening, versus once the builds are complete, how do I actually move it to a more of cheap and deep storage where you can have versions of your build residing there, but not only residing, but is also going to be protecting your data in case of any kind of a disaster, and also communicating or collaborating that with multiple sites. So this is an example of one of the products that we have used from a NetApp portfolio called StorageGRID. So StorageGRID is a product which we have used this integration where you ingest a file in one location, it automatically replicates the same file instantaneously to other locations. And the user on the other side, somewhere in Tokyo, can literally double-click on that file and download that entire file locally there. So that's the enablement, the integration that we have done enables the developers to actually go ahead and have that local version of the file available so that they don't have to go over the WAN every time to prefetch that data, so not prefetching, but fetching data on demand and then processing it locally. So what are the details of this entire collaboration? So the use cases that we targeted specifically for this is all about distributed file services. Think about DevOps, think about IoT or blockchain. They all require a distributed file sharing mechanism. And this is exactly the solution that we can propose, where you can not only have a collaborative effort, but also keeping the cost lower and still managing your data effectively. That's the key. So what are we trying to accomplish here? And why was NetApp chosen into this integration? So obviously, first of all, the performance was a key factor we ought to have. Second thing is that we want to keep a copy at the destination of all the locations as a read-write copy. That means you don't want to have a user say, okay, I see the file, but it's only a read-only file. I can't make any changes to it. How do I actually enable that? Oh, well, you need to go back and kill the replication process. You need to convert that into a read-write format, and then you start working on it. So that's another 2 or 3 iterations of operations you've got to go through in order to actually enable that. And then finally, the price, the cost factor that I was citing is the total cost of the ROI, the return of investment that you're actually getting out of it. With this integration, you're probably having a 1 cent per gig per month, which is, I think, the cheapest out in the industry today. The amount of data replication, and the replication is free. Whatever you're paying for your WAN connection, that's all you're paying. You're not paying anything for your additional replication. Storage is what you're paying. So the replication, whatever technology we are using to replicate the data is part of the product that you are already having it all set up in your on your local data center. So these are the main reasons why we actually decided to go through this, because it is just not solving one problem over there with collaboration, but you're also trying to solve the archiving, the protection, the cost, reducing cost, and the performance, all of that. So if I look into site 1 today, we all know that JFrog supports remote repositories, right? So what that means is the metadata gets replicated to all sites as soon as there is a change in one site, right? When you can double click on it, or I wouldn't say double click, but you want to list the changes on site 2 or site 3, you see all the changes there. But when you want to double click on the file, it goes back to the central location, it pulls the data from there. And we could have also done that on the data layer, just replicating the data. It's an array level replication from one side to another side, is just data replication. What we were trying to attempt here, or we have accomplished here, is the application aware data replication. That means the application knows where the data is residing. So from a user perspective, it has to be completely transparent for the developer or the user who is the end users who are accessing the files. Doesn't matter where it is staying, where it is located, but it can be downloadable at any given point of time. So this were the objectives that we started off trying to test all of these things. Performance was one of them. Then how do we actually have the same file, read, write, and then we can save those in the Artifactory. And then finally, data protection. Like we delete a file, and I will show you all of those things in our demo right after this presentation. So this is how it has been set up. You all know Artifactory has a database component and a repository where you have various different repos located. So you are putting together a consistent data volume, which is actually hosting your Artifactory components, the database as well as the Artifactory repository itself. Now you have got 2 instances of Artifactory running in 2 different sites, and we have got the NetApp StorageGRID product in both the locations. And if you notice, whenever you actually push an Artifactory or artifact inside the Artifactory after a build or any version change of an artifact that you are probably using, that change is immediately propagated to this other site. So when a user gets logged in into site 2 and tries to get a list of all the changes, you can not only see the changes, but when you double click on that particular file, that file should be available there locally. Now if I look at a global picture, and if I've got multiple instances of JFrog running, Artifactory running, you also have these components located locally over there, which enables as part of a global namespace. That means if you push one of the entries or changes over here, instantaneously that change is replicated to the other sites. So they're all part of the same grid, the same global namespace, where users who are actually having it present in different sites, they can actually see, not only see the file, but also download it. So the value that we're trying to provide here is, apart from all the good things that you're seeing with multi-push replication, S3 storage, and high availability from JFrog, we're also providing the data part where you're providing data access, continuity, security, and protection. So that is where you glue these things together as a complete business solution, where you say, okay, how do I take my local development team and have it available globally for them to collaborate and also come up with their desired product in a timely manner to the market. So that's the business goal that we're trying to accomplish here. And that is what we're trying to do, that as a joint integration, the value that we're providing, not only trying to do that at a tool level, like an Artifactory, but also how do you manage the data and protect that, and collaborate and have the right performance to enable the business. That's all I had. I would like to pause for a few minutes to take some questions before I start the demo. Yes?
How's the replication work with files that are big chunk of files that they get changed? Do you have the file replicated? Like, is it going to take the same size from the original source to the
Yes.
replicated size?
Yes. So what we do is, JFrog does the metadata update on the database, right? StorageGRID also have an ability to do metadata updates for the data part. The data also has some metadata as to what blocks, which directory structure, how big of a file it is, and all that information, the inode information basically. And that information gets replicated right away. And then starts the replication of the actual blocks. So that's the reason why you normally see that entire file or the directory structure that has been replicated as I said, this has all been displayed as a checksum for JFrog. When you look at the JFrog and the tree structure, and I'll show you in the demo, they're all a bunch of checksums. So those checksums are always having their own folders, which they are actually part of, right? So the entire file, irrespective of whatever size it is, it gets replicated right away. So there is 2 layers of caching happening. It's just not the caching of metadata at the Jfrog Artifactory layer, but also the metadata for the data, which is your inode information, the directory inodes, and all of that information for the file system also gets replicated instantaneously by StorageGRID. The actual blocks is what it takes time, because depending upon the WAN latency. If you have a faster speed, or we were testing with 170 millisecond, if you have got much more faster speed, like 150, maybe less, then it'll be a lot more faster. So the WAN speed is the limitation. But as soon as the file is replicated and is available locally, then it's a local download for you.
How did you get Artifactory to not try to send the binary content as part of the replication message? It'll be on the file system, sure, but Artifactory doesn't know that. It's just told, hey, I have this SHA checksum. I have this binary with the SHA checksum. It looks up the database and says, oh, I don't have that. And then the source system sends everything over. How'd you guys prevent that part?
We can actually set up the replication policies, right? We can set the policies in the beginning.
Policies can be there, yeah.
We can set up the replication policy, the artifact, and I think we'll show you that in the demo, where we are setting up a policy where we are deleting a file in one site, and the same file does not get deleted if we are not setting up the sync on delete option.
Maybe you should show the demo since it's quick, and then get more questions at the end.
Sure.
How does this compare against multi-region replication for S3? If it is S3 backed storage in Artifactory, how will this compare against that?
The comparison almost the same, but it is just that we are much more faster, the 6x performance improvement that you saw, as the cost also is way lower. So there are the 2 main guiding factors for us to highlight what you can do with a hyperscaler-based S3 replication, a cross-region replication, versus what we have done, is that because of 2 reasons. And these are the numbers which I think we jointly tested out and found out that the performance is 6x and the cost is like 1 cent per gig per month.
Yeah. Okay, I'll start a quick demo here.
So there are 2 different sites we have set up, and every site has got an Artifactory that is having the artifact volumes, the data volumes, are residing on NetApp storage, not on StorageGRID, but on NetApp storage, and I'll show you it is mounted over NFS. So when we are simulating the load, we are writing a script which is throwing a bunch of data options or text files into the Artifactory. And that is actually going onto the base platform, which is the performance platform, which is called ONTAP. And that is where the volumes are residing. And once the volumes are there, the data is there, then Artifactory goes and pushes those over S3 into object store, which is StorageGRID. And that's the one which is actually enabling you to replicate the data across the different sites. Okay, so here what we're doing is we are setting up 2 separate repos. Now these repos are generic repos, and the reason why we have got 2 separate repos because we are setting separate replication policies on both of them. And in both the sites you have got generic and generic local. The 2 repos, I'm not sure people in the back can see this because that's the best resolution I could have, but these are the different repos you're actually creating, and it's a generic repos. And once these repos are already up and running, we establish them. You see this over here. This is on the storage on the NetApp side of the ONTAP, which is mounted on NFS, the MySQL database, and the ART data, the ArtDB and ART data, site 1 and site 2. And they are basically in the file-based, because this is where you're pushing your artifacts in it. So all of them are mounted over NFS, and there is no traffic right now on the storage side. So once we start to ingest data into those repositories, then you start to see the traffic, and we'll be showing that in a minute. So now, once you have all of these set up, we need to set up the communication, the channel, the connectivity between these 2 sites. So it's a site 1, so we are trying to set up a repository, a policy, and a communication between the 2 sites. So this is a cron job that you're setting up. So this is the URL of the second site. And we'll check the kind of communication right away. You see this? Communication established. So now both the sites are talking to each other. And this is site 2. We're adding another repository. It's a generic local. Setting up the policy, the replication policy here. We test the connectivity. So here we're not checking the sync on deleted artifacts. So the reason because we'll be deleting an artifact in site 1, and we'll see how the artifacts are visible or not. So that's an option that we are selecting. That's the reason why we've got 2 separate repositories here. So you see both the repositories and both the sites right now. And if you open up these repositories in the browser, repository browser, you won't find anything. And this is a Cloudberry browser for checking all your checksums. And if you open up here in the different folders that you see here, there is nothing. It's all empty. And we'll start to run a script which is actually going to push a lot of artifacts or text files into the Artifactory. And you also saw earlier that the storage also is not having any data or any kind of an I/O traffic happening because there's nothing going on. So now we are firing up the script. It's going to start writing a bunch of 95 meg files, 100 of those. So as soon as you see this, we go to the storage side and you notice there is already traffic coming in. You see here on site number 1 there is already traffic coming in. Site 2 there is slowly traffic is picking up. And you will see the files getting replicated right away. So this is on site 1, and this is on site 2. There are a few files there, but it's slowly picking up. So from a listing perspective, the files are already there. So it has just happened instantaneously. We didn't have to wait for it. So the bottom line is, this is a complete S3 level or object level replication that is happening at the StorageGRID level, but Artifactory keeps track of where the files are located. And the entire metadata and the cataloging of all the files and indexing of the files are all being managed by Artifactory, and it's been updated as the replication is happening. So from a StorageGRID perspective, you cannot view those files without a Cloudberry browser. But what you can go here is the StorageGRID UI. You'll see the space has been taken up. If you see there is a flat line and immediately it has gone up, it shows that it was completely 0 bytes, and then immediately you see a spike in the capacity of the StorageGRID, because now you're writing files into it. So if you keep on refreshing that on your site 2, you will see a lot of these files showing up, because you got about, when we started off, we had 0 artifacts. By the end of this demo, we will be seeing some of the artifacts already in both the locations. So we are actually pushing a particular file called tar file. You see this, it's been pushed into the site 1. And then we'll be going and clicking on, the site 2, we're downloading this file. It's happening instantaneously. Now, this is a 1.5 gig file. And when you click on the file, it immediately starts to download. But when the download is happening, the file is not replicated yet because we are instantaneously trying to download it. But the WAN latency is the only bottleneck over there, but you see how fast the file got downloaded right away, the entire file. So depending upon how much latency that you have between your two sites, you literally can download your files instantaneously, and the size of the file too, it matters. So this is the file, and if you have accidentally deleted a file, depending upon the policy that you have set up, you can always recover the file from StorageGRID because the StorageGRID is your archival component. The file still resides there. So if you have accidentally, so like for example, over NFS, the file has been deleted, but the object is residing in StorageGRID, then that can be actually recovered from that place instantaneously. So we are just verifying the checksums to match the different sites. If you see here, this is the checksums that we are looking up for any random folder there, or a bucket. And we are selecting the same thing from site 2 and trying to figure out whether that is replicated or not, because Artifactory stores all of these in checksums. So we're going to data center 2 and looking for the same checksum. You see that? Both the checksums are the same, and we have the same file residing in both the location. This has a complete voiceover, and we are playing this video in our booth. If you have any further questions to ask more details about it, you are welcome to stop by and have a conversation about this. And this video will be also available for people to access it with all the information that we're presenting. So if you see here, we have got 51 artifacts in both the locations. And if you refresh the site 2 will also have 51 artifacts. So the bottom line is, what you're trying to achieve here is the same thing that I talked about in my presentation, is no matter how many sites you are having, which are part of the same grid and part of the same global namespace, the files have been replicated, and it will be available instantaneously for download, the similar file with the same checksum name. I'm open to take questions now. Yes?
So you check the sync deletes box, but Artifactory, unless you guys did something special to it, every time you upload an artifact in server A, it's configured to send it to server B, it's going to do that same negotiation where it's like, I have this checksum, do you have it? And then server B will say, no, I don't have it, send it to me. And so you might do this thing with StorageGRID where you're intelligently doing it at the block level, but like, how did you stop Artifactory from also trying to send it? Because it doesn't know anything about it.
So Artifactory is talking to us over S3. So when we deleted the file, the test.zar file on site 1, we honor whatever protocol S3 has. So StorageGRID would say, okay, I'm going to remove that particular checksum on site B, or whatever site it is. So we are literally moving it away completely. But now the question is then, how do we archive and what is the protection stuff happen there, right? Before you move the file onto the StorageGRID, you are taking a snapshot of the Artifactory. The snapshot is nothing but a checkpoint at a file level, not an object level, because you cannot take snapshot at the object layer, at least in our setup. So if you completely lose that out from the object store, that is StorageGRID, you can always fall back at the snapshot layer to get the snapshot and go back to the previous snapshot, recover the file. Yep. So we always have a plan B, a fail safe, if that file completely goes out of the object store because of the policy that you have set up, and you lose that file in both the locations and all the locations that are part of the grid, because of the policy that you have set up, the sync on delete. That means somebody deletes in site A and that gets deleted everywhere. You can always recover from the snapshot that you have created. And this is beyond the scope of this presentation, but we have also worked together with Jfrog to take application consistent snapshots of the database and the repository before they even push the files into object store. So we already have that. The reason because customer says, well, I also want to have another layer of backup to tape. So you already have StorageGRID. Then how do you actually take us back up to tape unless you have a consistent data set? To have a consistent data set, you can't take snapshot of the StorageGRID layer. What we do is we take a snapshot of this layer. Okay. There, we already have a snapshot available, so you can actually back it to tape. Even if you want to replicate it to AWS S3, whatever you want to do, we have all the capabilities available.
Yeah, the other solution we have is more towards backup.
Yeah.
Yeah.
So the backup part is where you back it up to tape, or you have a consistent point. So in case if this file gets deleted from these guys, you can always go back to the snapshot and recover that from there.
Can I control queuing on how this is done? When files get a lot of work?
Oh yeah, you can set policies. Yeah.
Okay, that's by policy.
Yeah, you can set policy at the Jfrog layer. You can set policy at the StorageGRID layer.
Both layers.
I need to shape my traffic depending on my network because Asia is much more distributed with multiple hops, and some of them have lower bandwidth overall. So I want the most important files to get there first.
Absolutely. I think I was having this conversation with somebody where they want to say, okay, this particular directory I want to have replicated. Then yes, you can absolutely specify that policy. Anything else?
All right. Any other question?
The great questions, by the way, and thanks for, yeah, you have any?
Yeah, the StorageGRID always will work only to represent how the replication setup, right? Well, my question will be, so anything that doesn't have replication setup won't have the sync up on the storage. So it's always attached to
the policy, yes, the policy, because that is the level of granularity that you're going to have or control over your data, because you don't want to expose your data in all the locations, and you want to restrict the usage of that. So you can actually set those policy up at Jfrog layer as to what repos you want to expose and what you want to replicate. And those are the ones who will be replicated.
Yeah, the control via Artifactory there.
Is there web APIs that we have access to do automations on the StorageGRID?
Oh yes, we do have APIs, RESTful APIs available for StorageGRID. We have RESTful APIs for StorageGRID. We have got RESTful APIs for ONTAP. Actually, the plugin that we actually work together to take the application snapshots, consistent snapshot, is using APIs to call consistence of data set and take a snapshot at this layer. And that is actually been taken by the user at the Jfrog layer, the artifact layer.
And RESTful API from Jfrog side, so yeah.
So it's all API based.
Yep.
You can customize it, you can play around whatever your business requirements are, absolutely can be done.
All right.
All right, thank you very much.
Thank you very much.